Good day, learners. Welcome to today's lesson. Today we're going to look at proving identities. But before we start, learners, there are a few fundamental things that you need to bear in mind. And this will be your recipe to success in understanding identities and how to solve them. So, the first thing is you need to have a good basic understanding of algebra. Okay? You must know factorization, common factor, and all those types of methods of factorization. That's going to be important for you to prove the identities. The next thing, learners, is you can use your tan and your square identities here, and also the manipulatives of your square identity, where you can make any component in your square identity the subject of the formula, right? So next thing, learners, is you are going to be required to simplify to prove the left hand side equal to the right hand side. You can do it but in two ways. Okay, one, you can look at the left hand side and prove that it is equal to your right hand side. That's the one way in which you can approach it. This is a more time saving one. This one consumes a bit more time, because for this one you simplify both sides until they are equal. Okay, so the example here will be an A-type example where I only need to simplify the left hand side to prove it's equal to my right hand side. And this example here is where I'm going to simplify both sides to prove the identity. But if you have applied all this and you know for a fact that you did this at 100%, you did that at 100%, you did all of that, and you get to a conclusion and you see your left hand side is not equal to your right hand side, that is fine. Because then you've proven that your left hand side is not equal to your right hand side, which can also sometimes be the case. So let's fall away and start with this one immediately. So first and foremost, learners, I will first see, is there something algebraic about this that I can do? So basically, I'm going to look at my left hand side first, and this is the part that I'm going to focus on, learners. Okay. So my point of departure would be to look at it from an algebraic perspective. So if I look at this, I can see that these are squares. That's a negative. So this will be difference between two squares. So what I will do in this case, learners, I will apply the rule of the difference between two squares where I expand. So I'm going to expand this expression, learners. Okay. So for my first bracket, I'm going to have sine squared x minus cos squared x. In my second bracket, I'm going to have sine squared x plus cos squared x. Okay. Now, the next thing I'm going to do, learners, once I have applied my algebra and I'm 100% confident that it's correct, I'm going to look at identities. And if I investigate, I can see that that is my square identity, which is equal to 1. So what do I have now? I now have sine squared x minus cos squared x times 1, because that's my square identity. Okay. Now, learners, when we get to this point, we now need to go and investigate further. What can I do now to simplify my expression further? So I want you to pause the video. Right, learners, so at this point, we should now ask ourselves, okay, right? We know the 1 is going to multiply out, and what I'm going to be left with is sine squared x minus cos squared x. Now, if you look at this and you look at your answer, you should be guided by your answer in terms of where you're going to touch, which part of this expression are you going to work with, and which one are you going to manipulate. So I'm going to go with sine squared x. Now, sine squared x, learners, the manipulative of that square identity is 1 minus cos squared x minus cos squared x. So again, here I have applied an identity, the square identity, learners. So what am I left with here now? I'm left here with 1 minus, there are 2 of these, which is my answer, 2 cos squared x, and therefore I can conclude by saying the left hand side is equal to my right hand side. And that's how you prove the left hand side equal to your right hand side in your identities. So this was an example such as A, we have to prove the left hand side equal to the right hand side. I'm going to give you an example now where we're going to have to simplify both at the same time in order for you to prove the identity. And you can choose what you're comfortable with, but I would not suggest you do this in the exams because it's going to take up much more of your time. So let's follow away later. So first things first, I'm going to look at what my left hand side is in conjunction what is on my right hand side. So the first thing I'm going to do here, learners, is I'm going to first again follow the rule. I'm going to look and see, is there any algebra I can apply here? And yes, of course, there's a square, there's a negative. So immediately my mind tells me I need to look at the difference between two squares. Okay, so therefore if I simplify, if I expand, I'm going to get sine theta minus cos theta times sine theta minus cos theta. Okay, so that's now for my numerator on the left hand side, divided by, now again learners, before we continue, let's see if there's any algebra in there. There's a sign, and we know when we work with the positive and the negative, we should always look out for common factors. I can see there's a cos theta, and there are two of them. So what I'm going to do now, learners, is I'm going to take out one on each side as my common factor. So I'm going to say cos theta. I'm left here on the left hand side, I'm left there with sine theta. So I put that in my bracket, okay, plus I'm left with one of those there, so it's cos theta. So now learners, if I look at my numerator and my denominator, I can see that this factor and that factor will cancel out. And I'm now left with sine theta over cos theta minus cos theta over cos theta. Okay, so from this here, I can say, if I apply identities here, I can say that tan theta is sine theta over cos theta minus 1. Now let's go further here on my left hand side. Here I bring this down. So this cancels out, that's 1. And on the left hand side, I'm left with sine theta over cos theta minus 1, which is equal to my right hand side. So therefore I can say that my left hand side is equal to my right hand side. And that's how you prove your identity.